using the discriminant. So the discriminant, when we're talking about our quadratic formula, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Our discriminant is this piece underneath the radical, so it's the b squared minus 4ac. When you solve the discriminant, that's going to tell you how many solutions you have on a graph. So if your discriminant is less than 0, so if it's a negative number, you're going to have no real solutions, or no real roots, which means that your graph is never going to touch the x-axis. If your discriminant is equal to 0, that means you're going to have one real root, which means you're going to have the maximum or the minimum touch your x-axis. Remember, for quadratic functions, we have parabolas, so U-shaped, either opening up or opening down. And if your discriminant is greater than 0, you'll have two real roots or solutions, which means it's going to cross your x-axis at two distinct points. So, for example 1, if I have negative 4x squared plus 12x minus 9, our equation that we're using is that b squared minus 4ac. So my b is 12, so I would have 12 squared minus 4 times a is negative 4 times my c is a negative 9. So now it's just solving. So 12 squared is 141. I have negative 4 and negative 9. I'm going to put a minus 4 here. When I multiply these two together, I get a positive 36. Again, orders of operations say to multiply first. So I'm going to have 141, and I'm going to take away 4 times 6 is 24. 4 times 3 is 12, 13, 14, so I have 144. When I subtract these, I get a negative 3. Since my answer is a negative, according to my rules, I'm going to have no real roots. Okay, if I look at example 2, in this case, my b, I don't have a b because I don't have a single x. If I were to rewrite this, I would have x squared plus 0x plus 25. So be mindful of that when you start solving these. So I don't have a b squared value because that's going to give me 0. 0 squared minus 4 times my a is a 1 times my c is a 25. So again, orders of operations, 0 times 0 is going to give me 0. Subtract 4 times 1 times 25 is 25. So I'm going to have 0 minus 100, which gives me negative 100, which again means that I'm going to have no real roots. My graph is not going to touch my x-axis at all. If I look at example 3, again, you're using b squared minus 4ac to figure out your discriminant. So my b is a 5, so I'm going to have 5 squared minus 4 times a is a 1 times c is a 4. 5 squared is going to give me 25 minus 4. 1 times 4 is also 4, so I'm going to have 25 minus 16, which is going to give me a positive 9. Since it's a positive, according to my information up here, d is greater than 0, that means I'm going to have two real roots. And I can actually solve those by factoring this. If I factored, I'm going to end up with x plus 4 and x plus 1 when I set those both equal to 0. X plus 4 equals 0 and x plus 1 equals 0. This is going to give me x is negative 4, and this is going to give me x is negative 1. So on my graph, when x is negative 1 and x is negative 4, that's where my parabola is going to cross. I know it's going to touch at positive 4 on my y-axis, and it's going to have some negative value. So this is roughly what that graph would look like. And for the last example, example 4, again, we're using b squared minus 4ac. So my b in this case is a negative 6, so I would have negative 6 squared minus 4 times my a is a 3, and my c is a 2. So negative 6 times negative 6 is going to give me a positive 36, minus 4 times 3 times 2 is 6. So I'm going to have 36 minus 24, which is going to give me a positive 12, which again, if I have a positive number, that means I'm going to have two real roots. And again, I can solve this by my factoring. I would need to know what multiply to give me 6 and add to give me a negative 6. So I have 1 and 6, I have 2 and 3. And it looks like I'm going to end up with a decimal, so I can't actually do these perfect squared pieces. So we're going to skip this whole graphing part. But you would end up with two real solutions because it's a positive number, but they're going to be decimals because they aren't perfect squares.